Okay, we continue our lecture in part 2 section. Okay, still in paper chromatography. Right, there are several classification of chromatography methods, which are liquid chromatography, which are separates liquid sample with a liquid solvent, act as a mobile phase, and a column composed of solid bits, which is a stationary phase. Okay, as I show in our previous slide, of the column chromatography is considered as a liquid chromatography. Right. So for gas chromatography, it separates the vaporized sample, okay, with a carrier gas. So this carrier gas will act as a mobile phase, and a column composed of a liquid or of solid bits is a stationary phase. Okay. So in GC, the sample must be vaporized. Okay, the properties of the sample mestilah bersifat meruap. Okay, so that the technique of the separation can be applied. Okay, right. So in paper chromatography, it separates dried liquid sample with a liquid solvent act as a mobile phase, and a paper strip act as a stationary phase. For thin layer chromatography, it separates dried liquid sample with a liquid solvent act as a mobile phase, and a glass plate covered with a thin layer of alumina or silica gel which act as a stationary phase. Okay, we look at the paper chromatography illustration, right? The paper chromatography is a technique that involves placing a small dot of a sample solution onto a strip of chromatography paper. So the material we use is a cellulose paper, which acts as a polar substance, right? So the adsorbent more polar substance bond with the cellulose paper more quickly, right? Means that if the substance is polar, okay, so it will interact, or it will bond with the paper strip more, it will spend more time, right, in the paper strip. Okay, so what you need to do is you need to draw a 1 cm line here. Okay, 1 cm distance line from the bottom. Okay, this is called as the origin line, and then you need to put the sample, okay, on the spot, okay, on the original line here. So if you have more than one sample, you can put the sample behind this and also behind this, like displayed in the diagram here. So in this diagram, they have three types of spot, right? So when the paper is immersed in the solvent, and then the dye will move towards the um, ascending, okay, the ascending method, okay, dia akan bergerak naik ke atas. Okay, there are two types of paper chromatography, which are by descending and ascending. So in this picture, it is ascending, which is means that the movement of the compound is upward. Okay, if descending, the movement of the compound is downward. So you need to make the solvent front. Okay, let's say if you want the sample to be reached at this line, so you need to make sure that um, the separation is complete. Okay, and the solvent is depend on you, whether you want to use a water or sodium chloride or so on. Okay, the paper is placed in a jar, also tank, containing a solvent such as ethanol or water, then it will be sealed. A small concentrated spot of solution that contains the sample of the solute is applied to a strip chromatography paper about 2 cm away from the base of the plate. Okay, it depends on your method, whether you want to use 1 cm or 2 cm. As the solvent rises through the paper, it meets the sample mixture, which starts to travel up the paper with the solvent, and the paper chromatography takes from several minutes to several hours. Okay, depend on the compound. Okay, different compounds in the sample mixture will travel at different rates, right? Due to the differences in solubility in the solvent and also due to the difference in their attraction to the fibers in the paper. All right, if we can see here, right? The ink spot, okay, contain only one dot of black ink, right? So after it is immersed in the solvent, so the black spot will separate into three types of color, three compound actually. So it will separate into yellow, pink, and blue color, right? So after several hours, okay, several minutes, and the blue one move faster, and the location of the blue dot is um, uh, on the bottom, and the location of the blue compound ataupun blue ink um, is on the top compared to the pink and yellow one. So it means that the blue compound separate more faster. Okay, and the second point is the blue compound. The blue compound has less tendency towards the stationary phase. It also spend less time in stationary phase and it move fastest, while the yellow one it spend more time in the stationary phase. It move slowest, right? Okay, the explanation. Okay, to further explain about the paper chromatography, okay, the compound in the mixture will be separated according to their ability of the solubility, which is the polarity. Okay, means that if the substance has more polar, okay, it will move faster. Okay, less polar substance will travel slower. Okay, I'm sorry. There is a typo in my slide. Okay, I will repeat again, right? More polar substance will move slower, okay? And less polar substance will travel faster. Why? Because as I mentioned earlier, paper strip is polar, okay? So kalau polar dengan polar, dia akan suka sama suka kan? Sebab benda compound yang awak nak separate tu pun polar. And then kertas tu pun polar. Kalau polar dengan polar, dia jadi suka sama suka, dia akan spend masa lama dalam tu. Dalam paper tu. Sebab paper tu stationary phase kan. Yang bergerak tu adalah compound kan. So dia akan spend masa lama dalam stationary phase. So dia akan bergerak perlahan lah. Okay. For material that has less polar, dia akan separate first. Dia yang paling laju sekali bergerak. Okay. So less polar maknanya dia sama ada dia memang non polar ataupun dia less polar. Okay. Then less polar then stationary phase. Okay. So less polar material dia akan move faster. Contohnya kalau awak tengok gambar paper strip tadi kan. Mana gambar paper strip tadi? Kalau contoh paper ni, gambar ni. Maknanya yang kuning ni dia adalah less polar because it move fastest. And the green one is considered as polar because it want to spend more time in the stationary phase. So it will elute ataupun dia akan separate lowest. Okay, lowest. Dia punya masa dia paling lambat keluar. So yang hijau tu paling polar. Okay, most polar. Okay, faham Don't get confused. Alright. So substance that having more solubility in the stationary phase will move slower. and the substance having less solubility in stationary phase will move faster. Okay, I hope you get a clear vision of this and don't get confused because it is very straightforward. Okay, we look at the mechanism of the paper chromatography in ascending mode. So in ascending means that the solvent move upward against the gravitational forces. And the only forces that cause the motion is called as a capillary force. So the speed of the process is slow. Okay, so the picture here is a ascending method. All right. Okay, the mechanism in ascending paper chromatography is the water in the mobile phase of the chromatography system. Okay, the paper is stationary phase. So the solvent move upward against the gravitational force, and the force that caused the motion is called as a capillary force. The speed is very slow. The different compound in the sample mixture travel at different rates due to the different insolubility and also different in their attraction to the fibers in the paper. So the mechanism actually, if the question asks you about the mechanism, you need to include all the points, right? So basically, if you want you to draw the diagram, so you need to have this diagram, or you can illustrate your own diagram. Okay, make sure you label the diagram properly and include all the points, right? All the important points here. Okay, for descending method, solvent is kept in a tube at the top of the chamber and is allowed to flow down the paper. So the liquid moves down by capillary action as well as by the gravitational force. So in this case, the flow is more rapid as compared to the ascending method. So in descending, the speed is fast compared to ascending. Okay, because of this rapid speed, the chromatography is complete in a comparatively shorter time, right? Okay, this one is the descending paper chromatography. We can see that the solvent is placed on the top, right? So the speed is fast. Okay, after development, the spot corresponding to different compound may be located by color. Okay, lepas kita dah buat testing ni kan, dia akan jadi macam ni lah. Several mixture ni dia akan separate kan. Macam mana korang nak tengok dia punya separation ni? Okay, first we can determine by um, look at the color separate, right? Can clearly see that the color, the spot can be differentiate based on the color, right? So kalau color ni still tak clear, you can observe through ultraviolet light, right? Or you can use also 9-hydrogen solution and also by treatment with iodine vapors, right? So for the chromatography paper, uh, we cannot see the chromatogram like in the instrument one. Okay, we cannot see the peak in the instrument, so we consider as resulted in the paper as a chromatogram. Okay, so it is different with the instrument. Okay, so kalau instrument kita akan nampak graph peak dia, right? Okay, retention factor. Okay, what is the retention factor? Okay, retention factor can be defined is the ratio of the distance traveled by the substance divided by the ratio of the distance traveled by the solvent. Okay, so if the retention factor value of a solution is 0, means that the solute remains in the stationary phase and thus it is immobile. Apa maksud dia retention factor ni? Berapa banyak value yang ditahan oleh um, um, chromatogram process tu, chromatography process tu. Okay, kalau retention factor dia kosong, maknanya tiada pergerakan compound dalam proses chromatography tu, proses separation tu. Okay, if the retention factor value is equal to 1, then the solute has no affinity for the stationary phase and travel with the solvent front. right? Kalau retention factor awak sama dengan 1, maksud dia solute tu adalah bahan yang kita nak separate tu. Solute tu dia tak ada tendency toward the stationary phase, and it travel with the solvent front. Dia macam um, dia macam terlalu, apa orang kata, terlalu laju dia punya speed dia. Okay, sampai tak dapat nak detect dia punya separation tu. Okay, if the final chromatogram can be compared with other known mixture chromatogram to identify sample mix using the retention factor value in an experiment. So how can we find the retention factor value? Right. So first thing, you need to measure the distance. Okay. Let's say if you have a green spot here of the sample. Okay. After a few minutes, the sample will move up to here. Okay, point here. So what you need to do is you come out the sample. Okay. Keluarkan sample from the tank, and then you leave it to dry about 10 minutes, right? So after that, you need to draw a solvent front line. Okay, you need to draw this line, and then you need to measure the distance from the solvent front to the original line here, right? And then you need to also draw the center of the point here to origin, right? So by using the formula, okay, you need to calculate the retention factor value, right? So this diagram, it show the value 2.1 divided by 2.8 is equal to 0.75. So it has no units.